Hello everyone, this is Vinothini working as an assistant professor in the Department of Computer Science and Engineering. Today I am going to take you a video lecture on hashing in data structures. Yes, as we all know, what is data structure? So data structure means it is a specialized format for organizing, processing, retrieving and storing the data. As we all know, the data structure is organized for storing the data and informations. In that data structure, we are going to see the topic on hashing. So what is hashing? Hashing means it is a technique which is used for storing the information, and whenever we want we can retrieve the information as quickly as possible. Okay. Then hashing means it is a technique that is used to identify a specific object from large group of objects. Okay. So for example, we can take our college database. So in our college database, if we want to search a particular students based on the index, we can search the students database and we can retrieve the student database based on the index easily. Okay. For this purpose only we are using this hashing. So for example, as I said earlier, we can take the example of student registrations in the universities. Okay. So in hashing, an object is given which is associated with a key value. Based on that key value only, we are going to perform the hashing techniques. Okay. So an object is assigned as a key to make it for the search purpose. Okay. So while we are storing the keys, we use the index values. Based on the index values only, we are going to store that values or data like something else. Okay. So we are having some steps to perform the hashing technique. Okay. So for the purpose of performing the hashing technique, we are going to use this two steps. So the first step is an element is converted into an integer. Whenever an element is given, we have to find that ASCII value for the particular element and we have to convert it into an integer. After converting it into an integer using the hash function, we can perform this hash function and we can store the values in the particular index so that we can retrieve the data as soon as possible whenever we require. Okay. So for this purpose, we are using this formula hash equals to hash function of key value. And the second step is the element is stored in the hash table where it can be quickly retrieved using hash key. For this key only, we are going to retrieve the data. Using this index value, we can easily search the data and we can easily retrieve the data. For this purpose only, we are using this hashing. So we have to follow these two steps for performing the hashing techniques. Okay. So we are having the various components of hashing. While we are performing the hashing technique, we have to follow this four components. The first one is hash function, the second one is hash table, and the third one is collisions, and the last one is collision resolution technique. Here the collision resolution technique means whenever the collision is occurring means we will follow some techniques in order to resolve that collision. So for that purpose only we are saying this technique as a collision resolution techniques, in which if we want to say simply means collision resolution technique means the techniques which is used to resolve the solutions. So collision. Okay. So the technique which is used to resolve the collision. If any collision occurs, we are going to resolve that collision means we can use this techniques. Okay. Some of the techniques are there. I'll explain you in the upcoming slide. Okay. So the first component is hash function. What is hash function? The hash function is a key which is used to transform it into an index value. Okay. So hash function means if we are given a key means we have to find some location in order to store that key. That location is known as index. Okay. So the hash function is used to transform the key into the index. So hash function should be mapped with that key value. Okay. So value is associated with the key. Okay. In that key only we have to in that index only we are going to insert the keys. Okay. So the value returned by a hash function is called as a hash value. So we are performing some operations, no, like if a key is given means the formula is hash of key which is equals to key mod of table size, that is our array size. So this is the formula for calculating the hash values. Okay, so the value which is while we are performing our operation in that formula, we'll get some value. That value is called as a hash value, or we can also say it as a hash code or hash sums, or simply we can say it as also hashes also we can say it. Okay, so next there is a types of hash functions. Okay, so there are various types of hash functions. What is the way hash function means? Division method. Okay, next folding method, painting method. We can say the folding method also we can say it as a painting method. Okay, so division method, mid square method, extraction method, radix method, like that we are having many number of methods. Okay, so in that, first of all we are going to see what is division method. Okay, so the division method is simply a key which is associated, a value which is associated with the key, that is called as the hashing. Okay, so we are finding some index value. Now in order to store that values, we are finding some index value. That value is if we are given a specific number of keys, that is specific number of values means we are finding the index value and we are storing that specific value in a certain index. Okay, so we are dividing the keys, according to their index. That is called as the division method. Okay, this is the earliest method which has been created for hash function. Okay, so the first order of business for the hash function is to compute an integer value. So if we are given an integer value means, based on this formula, that is h of k, k is nothing but it is the key value which is given for us. Okay, this is the key value which is associated with the value. Okay, so this is the k. Mod of n, n is nothing but it is the table size. Okay, n is nothing but it is a table size. So where we can we have to mention the table size, and we have to perform the calculation based on this formula. According to this, we will get a index value. In that index value only we are going to store that particular key. Okay, so for example, here I have given you an integer, that is our key value is 1501, that is 1501, and our n value is 10, that is our array size, or we can also say it as a table size. Okay, so our table size is 10. So based we are going to implement this values in this formula, while we will get some values. So we are going to store this 1501 in that particular index. Okay, so for example, if consider a table value, table size as 10 and a key value of 0. Okay, so where we have to implement h of 0 equals to 0 mod of 10. So obviously we will get the value, index value as 0. So that 0, the number, that is the key 0, has to be stored in the index value of 0. Like this only we will perform this division method. Okay, next is folding method. Okay, so folding method, in the upcoming slide I'll explain you a problem also based on this division method, folding method, and mid square method. Okay, next, what is folding? Folding means will be given a number of integers, that is one integer. For example, if you are giving 1 2 3 4 means 1 2 3 4, we have to split this integer into equal half, that is equal size. Okay, so these pieces are then added together to give a hash value result. Okay, in this folding we are having two kinds of folding. One is shift folding and the other one is boundary folding. Okay, the shift folding and the boundary folding. Okay, so next one is mid square function. Okay, so mid square function means if in folding method, if we want to divide, that is if we want to divide the given integer into equal half, if we are unable to divide that divide that integer into an equal half, we can also dividing the items into equal half. We can, if it is not able to divide equal half means, that is if 5 integers has been given, if 4 integers has been given means, we can easily divide it into 2 and the other one is 2. If we have been given as a 5 integer means, we can divide it as 2 and then the one integer also at the last. After dividing this integer, we have to add all these integers and we will get the one key value. That key value has to be associated with the key of the mod value, and we will get some index value. At that index value only we are going to store this 1 2 3 4, that integer. Okay, so next is mid square function. So in mid square function, if we are given an integer value like 11 means we have to take that 11's square value. Okay, so 11's square value means we will get some 121. In that the middle value, we are getting the middle value now 121. In that 121, that middle value is 2. So the 11 has to be stored in the second index, that is mid square function. Okay, so see I have solved you a problem in using division method, folding method and mid square method. See in division method, as I have earlier said, we are going to use this formula h of k equals to k mod of n, which is associated with the table size of 10. That is, the table size means our table size is 0 to 9. Okay. So the elements which we have to insert is 0, 89, 1 and 16. Okay. So first we are going to insert the element 0. We have to implement the 0 in this formula. So h of 0 equals to 0 mod of 10. As we know, 0 mod of 10 is 0. So this 0 has to be stored in the 0th location. Similarly, we are going to insert 89. So for 89 also we are going to insert this 89. For 89 mod 10 we are getting 9th index. So we are going to store this 89 in the 9th index. So similarly we have to perform the operations for 1 and 16. Okay. This is division method. Next, folding method. As I have said earlier, dividing, we have to going to divide the items into equal half. Okay. So we are going to divide the items into equal half. That is, we have the elements given is, that is the integers given is 1, 2, 3, 4, 5, 6, 7, 8 and 9, and our table size is 10. Similarly, we are going to draw the table size like this, that is 0 to 9. Our index value is 0 to 9. This is our array size, that is our table size. Okay. So here we are going to split this 1 to 9 elements into equal half. Okay. So we can divide it as 3, 3 and then 3. Okay. So like that we can split it. Okay. So we are going to that 1, 2, 3 plus 4, 5, 6 plus 7, 8, 9. We will get some integer value. That is our key value, which has to be associated with that table size. We will get some value, no? That is the index value where we are going to store that element. We are going to store that integer 1, 2, 3, 4, 5, 6, 7, 8 and 9. Next comes the mid square method. Okay. So the mid square method, the mid square method is, the elements we are going to insert is 10, 15 and 12. As I already said by theoretically, here I have solved you one problem. Okay. So our table size is 10. The element we are going to insert is 10, 15 and 12. So we are going to take this square value for this 10, square value for this 15 and square value for this 12. For 10 square we will get 100, for 15 square we will get 225 and for 12 square we will get 144. So the mid value we are getting now 0, 2 and 4. We are going to insert this 10 in the 0th index, and 15, this 2 is the mid value. So in the second index only we are going to insert this 15, and the third one is 12 square. So 12, we are going to insert this 12 in the 4th index. This is mid square method. So next is, we are going to calculate the load factor of the hash table. How we can calculate the load factor of the hash table? Why we are calculating this load factor? This load factor is calculated for the purpose of finding the efficiency of the hash table. So in order to find the efficiency of the hash table only, we are performing this load factor. This load factor is denoting by the symbol lambda. Okay. So the formula for calculating this load factor is, that is the formula for calculating the efficiency of the hash table is number of items in the table, which has to be divided by the table size. Okay. So we have to consolidate the number of items in the table and we have to divide it with the table size. Okay. Next. So for example, I am going to assume the table size as 10 and it consists of 6 items. Okay, that is 6 elements. So lambda equals to 6 divided by 10, 0.6. This is the efficiency of the hash table. That is the load factor. Load factor means, as I said earlier, load factor means we are going to calculate the efficiency of the hash table, how effective the hash table is, how efficiency the hash table is. For the calculation of that purpose only we are using this load factor. Next comes the last technique, the last method, that is collision resolution technique. As I already said, collision resolution technique, collision is nothing but while we are performing that hash function, okay. So for what purpose we are processing that hash function? In order to find the specific index for storing the specific datas or integers or specific databases, okay. So if already in some index already we have stored some datas, in that same index if you want to store another data means because the data is already stored in that zeroth index. For example, I am saying in zeroth index already we have stored the 0. Again if we want to we want to store the element 10 in the same index means that particular situation is called as collision. In order to resolve that collision only, we are following these methods for that resolution. Okay. So this is the resolution techniques. Separate chaining method, open addressing, rehashing and extendable hashing. Okay. So here I am going to explain you about the separate chaining method, open addressing. Okay. So the separate chaining method. In the separate chaining method, we are going to use the linked list concept. So you already know in linked list we are having two fields. The one field is data field and the other one is the address field. Okay. The data field stores the data and the address field holds the address of the stored data. Okay. So in this separate chaining can also be separate chaining, open addressing. In under open addressing we are getting linear probing, quadratic probing and double hashing. All these techniques are constructed in order to overcome some drawbacks in the previous technique. So for example, if we have performing linear probing, so we are also performing quadratic probing. Why we are going for quadratic probing? In order to overcome some drawbacks, there will be some drawbacks in the linear probing. So in order to overcome the drawback only we are getting into quadratic probing, same as double hashing. So in order to overcome some drawbacks in the quadratic probing only we are going to double hashing. Okay. So first of all I will explain you what is separate chaining. So separate chaining means we are using the linked list. As I already said, we are using the linked list. Okay. So see, in separate chaining, if I have solved you one example. So our given table size is 10. The input keys are, these are the input keys. Okay. Some 10 values has been given. Okay. So we are going to insert these keys into a particular index so that we can search it, so that we can retrieve the data whenever we need it. Okay. So the hash function is h of k equals to k mod of n. The k is the values which has given to us and the n is nothing but it is the array size, or we can also say it as a table size. Okay. So we are going to perform this hash of k, h of k equals to k mod of n, where k is the key value and n is the table size. Okay. So I am going to insert this 0. As in division method, whatever performance we have done, same as in the division method. So h of 0 equals to 0 mod of 10 equal to 0. So 0 has to be stored in the 0th location. Similarly 1 also going to be stored in the first element, first index. Next one is 4 is going to be stored in the 4th index. Next comes 9 is going to be stored in the 9th index. Okay. As usual 16 has to be stored in the 6th index. Okay. So next, now we are going to insert 36. Okay. So while we are inserting the 36, again our index value will become as 6. So in 6 already the data is stored. The data 16 is already stored in the 6th index. So this particular situation is called as collision. Now you understood what is collision? Whenever already a data is stored in an index and again another data has to be stored in the same index means this particular situation is called as collision. Okay. So in order to resolve this collision I am using separate chaining method. Okay. So in separate chaining what we are going to do is we are going to assign a separate link. Okay. Because we are using the linked list, so we are going to assign a separate chain, a separate link. Okay. So we are creating a separate link and we are inserting the value 49 in this separate data link. Okay, in this 9th index, the data is stored in the 9th index only, but in a separate linked list. Okay, again similarly we are going to store this 49 similarly the 9th index. Yeah. So in 9th index the data is already stored in the 9th index, so we cannot again store in the 9th index itself. So we are going for the linked list option, that is separate chaining method. Okay, so using the separate chaining method we are again creating another linked list, and we are storing this data 49 in this linked list. Okay, similarly for 64 and 81 we have to perform this same operation. This is separate chaining method. Next we are going to open addressing. So in open addressing, we are having three methods as I said earlier: linear probing, quadratic probing and double hashing. Okay, there is no more variations for linear probing, quadratic probing and double hashing. A simple variation only we are going to follow. Okay, so in open addressing, this open addressing is also can be said as closed hashing. Open addressing can also be said as closed hashing. Okay, so in this technique we are using a block of memory space which is reserved for storing the hash values. Okay, if any collision occurs, so I have already said you what is collision and how the situation is occurred. If any collision occurs means it is an alternative way. In order to resolve that collision technique only we are going under open addressing. So this is the hash function for open addressing. Hi of x equals to hash of x plus f of I mod of table size. Okay. Next we are going for linear probing. So what is linear probing? So linear probing means probing is a process of getting next available hash table array cell. Okay. In linear probing we are using f of I as a linear function. Okay. In quadratic probing we will use f of I equals to I square. Okay. In double hashing we are going to use these two formulas. Okay. So I will say you what is linear probing. So in linear probing, if collision occur means we are going for f of I, the function f of I. Okay. So in separate chaining, if collision occur means we have created a separate chain and we have inserted the values in that layer. But in linear probing, what we are going to do is, if collision occur means we are going to perform f of I operation. That is f of I means the first f of I will goes for f of 1, that is one step after the collision. If also collision occurs, in that next step also we are going for f of 2, that is second after the collision occurs. So for example we are going to insert this 89, 18, 49, 58 and 69 and our table size is 10. Okay. So for 89, hash of 89, that is 89 mod of 10 means 9th location. 89 mod of 10 is 9. Okay. So in 9th location I am going to insert this 89. Okay. Next in 18 வந்துட்டு I am going to insert in the 8th location 18. Again 49. Again 49 for 49 again 9th location. I am going to insert the element in the 9th location. Already in 9th location the element 89 is inserted. Yeah. So this condition is called as the collision occurrence. Okay. This condition is called as the collision occurrence. So in order to resolve this technique, I am going to use this linear probing. That is in 18 and see in 9th location 89 has been inserted. So I am going for f of I, the hash function f of I. Okay. So f of I means f of 1 step next. So this is the 9th index, 89 already inserted. After 89 one step next, so 49. Like that only we are going to insert in linear probing. As in double hashing means in linear probing we have used f of I, that is f of 1, f of 2, f of 3 like that. But in double hashing what we are going to do is f of I square. Okay, that is f of 1 square, f of 2 square, f of 3 square. Okay, like that I am going to use. See in 89, so 89 is inserted in 9th index, 18 is inserted in 18th index. Okay, yeah. Sorry, 8th index. Okay, 18 is inserted in 8th index. Again if I want to insert 49 means 49 has to be inserted in the 9th index. So the collision has been occurred. Yeah. So I was unable to insert this 49 in this 9th location. So I am going for f of I. That is f of I is f of 1 square. So 1 square, f of 1 square is 1. So 1 f is equals to 1. Yeah. So after this 9th location, next one step 49. Okay. So next 58. I am going to insert this 58. 58 in 8th index only we are going to insert. So already collision is already 18 is inserted in the 8th index. So collision occurred. Yeah. So I was unable to insert this 58 in this 8th location. So I am going for f of I square. So f of 1 square. F of 1 square means 1. So one step. In 9th index also the element is there. So I cannot use that f of 1 square. So I am going for f of 2 square. Okay. So f of 2 square. So f of 2 square is 4. So f of 2 square is 4 means from the 8th index I am going 4 steps forward. 1, 2, 3 and 4. Next I am going to insert this 58 in the 2nd index. Like that only we have to formulate this double hashing. Okay. This is double hashing. Okay.